size data set. Okay, so usually we have learned to load the data set using read underscore CSV method, right? So here using sklearn, you can also load your data set using sklearn.dataset. So this is how you can load it. From sklearn.dataset, import load post. So this is the name. Okay. So here you're going to initialize. Initialize the data set. Okay. Then in order to print, you can use your usual print method from the Python and the data frame name. So data frame name given here is positive. Execute it. So this is all the prices of the houses. Okay. So these are the different libraries that we are going to learn about. We do already know about the pandas, numpy. Okay, pandas for your data analysis and numpy for the numerical calculations. And here we are having linear model. Okay, sklearn. From sklearn library, we are going to use linear model. Okay, then from sklearn, we do have a model selection where we are going to split our data into train and test data sets. Okay, then the very first thing that we will do after we have loaded our data is we are going to split our data into dependent and independent variables. Now, what is dependent and independent? Independent is nothing but the x, okay, that are nothing but the feature names that you will be having on which your dependent variable will be calculated on. Okay, whereas y is the target variable or the dependent variable. Okay, so here you can see df underscore x. This is my x variable, that is the independent one. What I want from my x variable, I want the columns of the data set. So what is my data frame? Data frame is Boston dot data. I'm converted this data, which is a series, that into a data frame. So pd dot data frame in bracket Boston dot data and the columns of that data. So these are the columns that are my independent variable or the x values. Okay. Now talking about df underscore y, that is the dependent one or the target one. I'm going to set this as my target. So pd dot data frame Boston dot target. Okay. Now let's describe our data frame x. So df underscore x, you can see the mean, standard, minimum, maximum, and the quartiles. Okay. So these is given by your df underscore x described. In order to get the dimension, you can either use endim or you can use your shape. So df underscore x will give you the shape so as to know how many rows and columns are available. From here you can see there are 506 records and you have 13 features or columns. So which are the columns that can be derived using this command, that is df underscore x dot column. So you can see the column names are being given as a list. Okay, done. In order to build a regression model, you need to initialize it. Okay, so we are going to initialize our linear regression model. Okay, so let the variable be reg equals to linear underscore model that has been imported earlier, this thing, dot linear regression. Initialize your model, then split your data into 67 training and 33 testing. This is totally dependent on you, how much you want to split the data. Okay, so what are the different variables that you want to split in? X train, Y train, X test, Y test. Okay, so you're going to separate training data set and testing data set. So how are you going to split it? You are going to split it in 67% and 33%. So this will be done using train underscore test underscore split method. So in this method, you will be passing X and Y. Okay, the independent and dependent variables, comma, test size. So what is the testing data set size? So here you can see it is 0.33. That is the test data set. So automatically 67 will be your training data set. So random state. So random state you can take it as 42 or 010 or 101, whatever it is. Why do we require random state over here? We require random state so as to have the same samples to be used for training as well as for your testing. Okay. So next, in order to train your model, you will be using a method named as fit. Okay. So what are you going to, now you know that training model is the X and Y train data set, right? So rec.fit is the method and the parameters that you will be passing is X train and Y train. So do not get confused between your X test and X train. Okay, so whenever you are going to train the model, you need to pass the training independent and dependent variables to the uh, fit method. Just, just a minute, let me execute it one by one. You can see over here that it has shown as it has been trained for the linear regression. Okay, now to find out the coefficients of each of the features or each of the columns. So you do have COEF, that is coefficient underscore. In order to have the coefficient of the model, you can use what is the model variable, that is reg dot coef. Okay, so coef of the complete columns. So here you can see the coefficients. Okay, so this will decide how is the relation between the columns. Now next is, once we have trained our data, now we need to test our data. In order to test our data according to our EDA exploratory data analysis, the second last step is to test our data where the input is giving the trained one. So here you can see y predict is my variable name and I'm going to use predict method. Okay, predict method and the input given is x test. So if I give the input as x test and if I print, we can see 24, 7, 18, 21, 27. So this is what is the predicted output for our model. Now, what are the actual values? Just check the actual values. So the actual values are 23, 32, 13, 27. Check with this. If you try to check, it is some or less the same. Okay. So now how do we find the accuracy of that data? So that can be done using mean squared error. Okay. Now in order to use mean squared error method, that is available in your numpy, that is np. Okay. So print np dot mean of y predictions minus the y test, the whole square. So if you can see over here, it is 20, 20.72. You can check the same using the sklearn matrix. Okay, that here we have available mean squared error. Okay, again the parameters that are to be passed are y test and y predictions. So here print mean underscore squared underscore error in bracket y test y predict. So you can see over here it is 20.72. Here also it is 20.72. So this is how we analyze our linear model. Okay. Now this you have understood about the linear model. Okay. We have now here you can see I'm using the train.csv data set. and using read underscore CSV, I'm going to load the data into my data frame. So the different libraries are pandas, numpy, then sklearn linear model, okay, then sklearn model selection for train test split. Then here we are going to learn one more, that is Seaborn, and as we are going to use data visualization as uh, alternate, that is being done in matplotlib. So here you can see we have imported matplotlib.pyplot as PLT. Now percent matplotlib inline, this is the one that will make this compatible to this file. Okay, and then import math. Now we have read it in data frame, that is df. In order to get the first 10 records, you need to use head. Okay, so df dot head in bracket 10 will give you the first 10 records. Now what if I want to know the count of the record? So that can be done using your shape, or else you can have your simple Python, that number of passengers traveling in the original data as concatenate with the string method and the length of df.index. So this is nothing but your index, right? So this will give you the result as 891, or else you can just go for df.shape. So even that will give you 891 as your record set. Then the second step is to analyze your data. Now how are you going to analyze the data? Depending on the different plots. Now in order to plot, so why are you going to analyze this? So let's see SNS dot count plot. Now what is SNS? SNS is nothing but the Seaborn library, that is been abbreviated as SNS. Okay. So you have a count plot, that is to know that how many survived from the data set. So the syntax is as the SNS dot count plot in bracket x equals to survived comma data. Which data set you are using? We are using the data set as df. Okay. So here, once you execute this, you get a plot. Here you get on the x-axis as survived and the count. So 0 is the one that have perished, and 1 is the one that have survived. You can see many have lost their lives, whereas almost 350 have survived. So this is how you can analyze depending on your count plot. So we will have one more count plot dependent on the gender. Okay. So here you can see we have one more parameter used in our count plot. So on X you have survived, whereas you have categorized your count plot depending on the gender. So here you can see blue stands for male and orange stands for female. So here you can see that the count of count of female is 3 times more than your count of male that have survived. Okay, so here you can see count of female has more or less 3 times more than your count of males that have survived. And let's analyze one more, that is depending on the P class, passenger classes. So here we can see we have 1, 2, and 3 passenger classes. From here we can see that the passengers, those who are traveling in the class 1, have survived the max. Okay, over here. Okay, whereas the passengers, those who are traveling in the passenger class 2, have the less count. Now, plotting and histogram. This is an alternate to your distribution plot or the disk plot. So if you want to plot a histogram on a specific column, then you can give it as df in bracket the column name, okay, dot plot dot hist. Okay, so here you can see it has plotted a histogram. Over here, from this you can analyze that the youngsters, that is from the age 0 to 30. Okay, so these were traveling majorly in that Titanic. Okay. Then next we have fare. Depending on fare, you have the histogram as this. So the passengers, excuse me. So with the 08, okay, so they were maximum. Then over here, if we try to distribute this depending on the bins are nothing but the filled bars. So how many bars do you want? So if these are to be adjusted, then that can be given by bins, and the figure size is 10 by 5. So this is more elaborative than this. So this is, you can see over here, this is more elaborative to get the actual analysis. Now next we have df.info to have the summary of all the columns which are null, not null, and the data type of all. So here you can see passenger ID is of data type int 64, then age is of data type float 64, whereas you have few values in it. Okay, so in order to check the summary of your data frame, then you can use .info. Let's plot one more count plot depending on the sublinks and the spouse. So here you can find out the sublinks and the spouse. So you have the single persons that are traveling majorly. Okay. So in order to find out the null values, you can use df dot is null dot sum. So you can get the direct value that the age column has 177 records or the values in it as nan values. And in cabin you have 687 records. In embark you have 2. Now this can be visualized using heat map. Okay, so SNS.heatmap. The heat map is a method that is from the library SNS, that is CMON. Okay, from SNS that heat map, you're going to pass on how many the null value are there, and then make the white tick labels as false. So you can get the records here. You can see wherever you can find the white dashes over here. So these are nothing but the non values. Okay, so you can see clearly that the cabin has maximum non values, age has few of them. Now whether you need to decide is these columns required for an analysis or not. If they are not required, then you can directly drop out those columns, else you need to handle those non values. One more attribute in your heat map is using your color map. Okay, so in order to colorify your, so this looks better than your black and white. The same thing using this attribute, that is CMAP, for the distribution. Okay, the next, what is a box plot? Box plot over here, depending on x and y, that is p class and age. You can see over here p class and age. This gives the quartile. The center line gives the 50% quartile, whereas the lower line gives you 25%, upper line gives you 75% of that quartile. So as to get you the IRQ, it is most beneficial plot of that data. From this, you can predict that age in 1 and 2 P classes are more than that of your 3. So this is maximum. Okay. The next is imputation. In order to use imputations, you can either use fill any or you can use a method. So that can be used to replace a value of a non value in your data set. Okay, so here let's check df dot head. Here itself you can see in the cabin you have multiple non values. Now check if it is required for your data analysis. If not, then you can directly drop off that column. So you will use df.drop the column name access 1 in place 2. In place 2 will be required so as to have an effect in the original dataset as well. Now if you check the head, you can see that cabin column is being removed. Now in order to remove the all non records, you can use df.drop na. Okay, so drop any is a method that is not a number method. So that can be removed or using drop any. Now, if you check with the heat map to visualize that if you have any values or not, then you can see it is a clear black that has no white bars in it. That means you are not having any null values. But only to verify it, you can use our usual method, that is null.sum. From here, you can check all are zeros. That means now you have no null values. Check the head. Everywhere you cannot have your NaN values. Now, here you can see you have a categorical data or the string type of data, gender, embark. Okay, so these are to be converted in your numerical ones. So as to convert them, you can use a method named as getDummies from pandas library. Okay, so pd.getDummies from pandas library, we are going to use it for gender. So as to have the numerical data instead of the categorical one. So here you can see the after execution, you can see female and male. They have categorized. Here it says that it is 1 for female and 0 for male. And here it says that it is 1 for male and 0 for female. But now we do not require these two columns. We require any one of them because as we know, we have only two values over here. That means that if here it is a 0 for male and here it is 1 for male, that means it is completely understood that one of the value stands for female and one of the value stands for male. So we can remove the first column. So that can be done using drop underscore first equals to true. Use a variable gen to get the data stored. Now if you check the head, you can see we have left off with only one column, that is male. Okay. Similarly, you can apply it for your embark as we have S and C. Okay. The state names. So here you can see we again have QS. If you see in the data, we do have three options in embark. Here, Q, S, and C. Okay. So it is totally understood that if it does not belong to Q, it does not belong to S, then it will be belonging to your C. So for that reason, we have, in order to reduce our data, we are using drop underscore first equals to true, so that the C column is being removed off. Okay. Similarly, get the dummies for your P classes. Here again, we have 1, 2, 3 as the classes. If the passenger does not belong to 2 and 3, it will belong to 1. That is known. So we are going to drop the first column. So you can see the first column has been removed and we are left out with the two classes, that is 2 and 3. Now, we have already got the dummies for the three columns. So we can drop off the unrequired columns that are gender, embark, ticket, name, and P class, right? So once you drop it, check it. So you can see over here that we have left with the other columns. Now, we need to join the dummies with this data frame. So we will use concat method of the pandas with the dummies variable. So df equals to pd dot concat. Which data set? Again, the same data set, that is df. Then gen is the variable for gender, embark is for embark, and ppl is for class. So here you can see if we execute, we are joined our data set with male, qs, and 2, 3 instead of female, cqs, and 1, 2, 3. Okay, so this is what is done in your data reduction. Okay, we left out with dropping our P class that we have already concatenated with 2 and 3. Now, if you try to view your data frame, it says passenger ID survived 8, sibling spouse, parent child, pair, male, QS23. Okay, so this is what is our data frame left out. Now, you have your data set ready. Now, you need to train your data set. Now, in order to train your data set, you need to identify which are the X and which are the Y. That is, which are the dependent and which are the independent variables. Now, we want to check whether they have survived or not. Okay, whether they have survived or not. This is the question. That means you are going to work on the logistic model, either yes or no. Okay, so your Y will be DF in bracket survived, and X will be the rest of all other than survived. Okay, so that can be given by df dot drop survived comma access 1. So that means all records. Okay, now you have your X and Y identified. Then you can use your model selection for train and split data. Decide the split of data that you want to. Now here you can see the test size is given by zero point 0.3. That means you're going to divide your data in train and set. At training is 70% and testing is 30%. Now here the random state is given by 1. Okay. Next is to import your logistic regression, as our problem is about whether it is survived or not. Okay. So you are going to import logistic regression. Then initialize the logistic regression model. So we have log model equals to logistic regression. Okay. Now if you are going to train your data, so you'll be using your fit method for the model and pass on your training independent and dependent variables. Once you do this, you can find the resultant, the feature names. Okay. Then prediction. Now what is the prediction? Predictions will be nothing but that will be dependent on your X test. Okay. So predict X test. Once you do this, now here you come up with your confusion matrix. In order to get your confusion matrix, you need to import it from the sklearn matrix. Okay. Just a second. So here you have to check the accuracy. You can see I'm passing confusion matrix method, Y test and predictions. So as a result, you can see we have a confusion matrix as 103, 23, 26, 62. Now if you try to check this with you for in